Hey, today we're looking at trigonometry. There's some formula. Fun. We're going to look at two questions, and they're both from 2023. So in this question we're going to show an equation and that it can be written in another form. So this is what we often do with identities. So let's rewrite it there. Now we're going to have to rearrange but also substitute a lot with these kinds of questions. Let's go back to the formula, which is not exciting, but you kind of need to know these. They might be on your formula sheets and so on, but you should know them off. You should know how they work. If you look at, for instance, tan, the compound formula, you can actually use that as a proof to remember sine and cosine. So just have a look at them and look over them and try to have them ready before you do these questions. So cotangent squared is equal to cosine squared theta over sine squared theta. Can we change something else? Yes, we have a double angle here for cosine. So let's replace it with one of them. And you'll have to get used to which one to pick for the cosine especially, because there's three types. We're looking for sine in our answer, so maybe put in what sine is. And that's kind of, the general gist of these. A little bit of a guessing game, but you get used to it once you practice a number of questions. So we're just rewriting that there, and I'm multiplying across by sine actually. So multiplying everything by sine squared theta underneath. Okay? From here, we're getting closer. I can see that we have a 4 sine to the power of 4. You might remember from last year, you had sine squared theta plus cosine squared theta equals 1. We've just substituted one of them in, rearranged a little bit. Again, everything else stays more or less the same. So often there's this one little change as you go along. Don't do it all in one go. Just make sure you're doing it nice and easily for yourself, step by step. It's procedure. We do procedure in maths, don't we? Okay, we have our answer pretty much there. So if you put those together, you'll see you'll have sine to the power of 4 is already there. And for our squares, so sine squared theta. And you'll have 3. And then, of course, our 1 at the front. We've changed our signs, so it's minus 1. All equal to 0, and that's written in the form as given. In our next question, we have hence, which tells us that we'll be using something or our whole answer from the previous question. So let's just check it's the same. Yeah, same equation. So we're going to be solving for this. So when you see something like this, it's often disguised. You might have remembered a hidden quadratic was a question in grade 11. So we're substituting in, we'd say y, or any variable, is equal to sine squared theta. And from there, of course, we can write it then as 4y squared plus 3y minus 1. And again, we can factorize, hopefully. And if you can, that's great. If not, use the quadratic formula, for instance. So we've sine squared theta is equal to y, so let's again do that last part. Remember to do this last part, of course, where you put it back in. So sine squared theta is 1/4 and also minus 1. So sine is equal to plus or minus 1 over 2, and sine is equal to root of minus 1, which famously leads us into a different branch of maths. You'll be doing that soon enough, complex numbers. Well, that particular number anyway. Maybe not with trigonometry as much. Okay, so you'll end up with plus 1/2 and minus 1/2. You can use your cast, your unit circle. You can use your graphs. So I know already that 1/2 for sine is 30, and take away from 180 is 150, and then the same for the minus 1/2. I'm going to do the last, what I just mentioned. I'm going to put in the graph there. Just a quick sketch, just to look at it. So you know that when sine is 30, there it is, and obviously there's another value there. And if you think about it, it is 180 minus that for sine. And the same for the negative numbers as well. And the same with the cast system. Like you could have positive for all of them at between 0 and 90, so 30 degrees. 150 is positive for sine, but it's not positive for the other values, as you can see from the graph. So both ways are complementary, and you can use use just one of them, of course, just to demonstrate and prove for yourself that you're correct with your positive or negative values, and so on and so forth with these kinds of questions. Okay, so that's full question 2023, and there's another one, which is quite not unusual, but we often just get the equations or identities. We have a reciprocal graph question here. So we have a range of 0 to pi over 2, which is 90 degrees. I've written out my graphs already just to have it ready. So I've done this in advance. Cotangent is there. As you can see, we have our asymptotes. This is the first part of this unit. So you just have to learn how to look. And we have 2 minus cosine x, so we have transformation here, or 2. There's cosine there. Now I'm not leaving it there, we know what cosine is. So there it is from 1 to minus 1, and also 0 to 2 pi. Now I'm going to do the reflections minus cosine x. So it's a reflection, the x-axis there, and we have a transformation of, well, a translation of 2. So it's going up 2 as well. So it's going to go from minus 1 on the on the y-axis to plus 1, and go up from there. And another thing we have to look at is we're only within the range restriction of 0 to pi over 2. So we're going to draw little graphs now of that. So there's 1, and where does our cosine go? Well, it kind of just goes up, as you can see there. So just a sketch. We're more or less accurate enough. Next part, we see a cotangent. So it went down, as you see there, within that blue restriction part I have there. And let's put them together now. So we did our pair of graphs, and putting them together now on the same. And you'll see there's one intersection. So 1 root in the interval as given. So that's a nice little question. That's not something I've seen much of. But again, know these reciprocal graphs and how they work. And just putting the little bits there, that was the cosine part. I did the whole thing in one go, so to speak. There is y is equal to 2 minus cosine x, just within that restriction. Same for the cotangent there. And then all together at the end. Incidentally, part B of this question is leading into numerical solutions, which is a further unit, so we'll leave that for now.